So when you multiply the numerator and denominator with this, so obviously what you are getting is multiplication of the top one is secant square theta minus tan square theta. Okay, and so divide by the secant theta minus tan theta. Okay, I didn't want to mute it, but I just, because that's a cooker sound coming out, right? So and recording, I just stopped for a while. Okay, so secant square theta minus tan square theta divided by secant theta minus tan theta. This is what you will get after this a plus b into a minus b. You get this, right? So the top one numerator will stay become 1, and the denominator is secant theta minus tan theta. So which is nothing but this is what we need to be proving. This is the same as this. So this is one way of doing it. The other way of doing it is same question. You got secant theta plus tan theta equals to 1 over secant theta minus tan theta. So go from RHS, because you are seeing the 1 here, and replace 1 with the second formula what we gave, and that means you are replacing 1 with secant square theta minus tan square theta over secant theta minus tan theta. Then you write this is in a square minus b square divided by a minus b. So write as a plus b into a minus b, secant theta plus tan theta into secant theta minus tan theta, okay, divided by secant theta minus tan theta. So this gets cancelled, and you have whatever is the one on the left hand side. Okay, this is nothing but this. Okay, so these are the ways. Yeah, mean when you are there, I think I looked through the sheet what you have sent. In fact, it is a lot of questions are there. Okay, these are the questions. So of course they call that also as identities, but in fact all that is a worksheet. Okay, so I pick up the first question from the worksheet. Did she do something from there or no? Okay, yeah, okay, yeah, fine. So I think that what we probably need to be using is try first algebraic simplifications, so that you get something closer to, you get to use either 1, 2 or 3 of the identities what we have covered. Okay, this is the first step what you have to look at. The second one, if there is no algebraic simplification visible, okay, then you should see which of the 1, 2 or 3 to be used. This is the one you should be looking at. And the third trick is, should we start from RHS instead of LHS? From RHS, right hand side of the identity, right side. Okay, so sometimes it's easy to start from right side and move back. Okay, so to look at the question what she has given in the first, he has given, so is secant to the power of 4 theta minus tan to the power of 4 theta. Is that the one, or sine to the power of 4? Sine to the power of 4, yeah. Sine to the power of 4 theta minus cos to the power of 4 theta equals to sine square theta minus cos square theta. This is what he's asking us to prove this identity. So just because we are seeing this 4 here in both the cases, so this calls for, first is the algebraic simplification. So that calls for the algebraic simplification, right? So we need to use some algebra for this 4. What is that? Then we have to remember this as, it is something like a to the power of 4 minus b to the power of 4, right? Hello? Yeah. Yeah. So that means you have a squared whole squared minus b squared whole squared. So something squared and something squared. So this is written as a squared plus b squared. That means whatever is there you should add them once, multiplied by a squared minus b squared. So writing this, yeah, multiply. So you can consider this as a p, and then q, it's nothing but p squared minus q squared. You write so p plus q into p minus q or something like that. So in our case, a is nothing but sine theta. So when we substitute this back into this, so we will be putting this as a is nothing but sine theta, and therefore I write it as sine square theta plus cos square theta multiplied by sine square theta minus cos square theta. Right. So this is how it gets simplified. If we don't say that you need to do algebraic simplification, then you will be wondering, is this three different techniques for a different question? No, I think this is how the pattern falls. Okay. So this being 1, yeah, this being 1, so you get this, we use the identity which is 1, so you get the answer as sine square theta minus cos square theta, which is what we need to prove. Done. Okay. So the next question, I think I should pick up the next question from probably the yeah, the worksheet. Okay. Now I think I could open. So this is the one, right? 1 plus tan a whole square plus 1 minus tan a whole square equals to 2 secant squared a. So yeah, 1 plus tan a whole squared plus 1 minus tan a whole squared equals to, so 2 secant squared a or something like that. You have 2 secant squared a. Okay, this is what is that to be proved. So question number 1, as usual, said, do I use some algebraic simplification? If yes, what is that? Okay, so where, sorry, yeah, oh, proof, yeah. So this is the algebraic simplification because there's a square here, right? So that means there's something like a plus b whole squared plus a minus b whole squared. So a is 1 and b is tan a. So we use algebra saying that it's a squared plus 2ab plus b squared. Then for this plus a squared minus 2ab plus b squared. Don't play with the trigonometry till you simplify this actually. Okay, better to do that. So this 2ab gets cancelled. Then what we have is 2 times of a square is there. Okay, but just write it as a square plus b square and a square plus b square. So write a square plus b square one time and plus a square plus b square another time. Now you substitute a for 1 plus b square is tan squared a plus one more time 1 plus tan squared a. So this is the second identity. Yeah, so you will have secant squared a plus secant squared a, you will get 2 secant squared a. Okay, I mean people do it directly saying that okay, this is this, they skip this part, directly write this, and then yeah, this is a better way because you don't have to remember multiple techniques. So we are looking at saying algebra is to be used, so we use the algebra first and then simplify that. Okay, so third question, is it easier for you to do the third question? Can I do that one also? Okay, so let me see that. Okay, cot to the power of 4a plus cot square a equal to cosecant 4a plus cosecant square a. Okay, cot to the power of 4a plus cosecant squared a equals to cot to the power of 4a minus cosecant squared a. So this is what is to be proved from left side to right side. Oh, I missed a here. I missed a. Cot to the power of 4a, and this is what it is. So obviously, is this the one? Did I copy it wrong? Cot to the power of 4 plus cot square a. Yeah, I think I copied it wrong. Plus cot square a, the other way around. So this one plus cot square a equal to cosecant to the power of 4a plus cosecant squared a. Correct? Is that the correct one I copied now this time? No? Some minus is there. There is a minus. Yeah, minus is there. Here's the minus. Yeah. So you have this minus cosecant squared a. So now we have to look at which one is better to do. And okay, first of all, we have got this to the power of 4 is there. Okay, to the power of 4. That's why you first write that as a cot squared a whole squared plus cot squared a. No, a won't get squared. It's only the, yeah, a remains, a is the angle. We don't square the angle. Yeah, we don't square the angle unless it is given. Okay, so we have this. Now from this you can take cot square a common from both. You are pulling out cot square a. When you pull out cot square a, there is one more cot square, right? And then plus 1. Okay, plus 1, because only one cot square a is there, right? Not understood. Okay, so we have, for example, a to the power of 4 minus a squared. We write this as a squared whole squared minus a squared. We take out a squared common, pull out. So one more a square there in the front one, and here one remaining, isn't it? Okay, if you do plus obviously, right? So I think I did the all others do, like, I didn't explain the algebra part and I went straight, then that's how we got the issue. Okay, anyway, so we got this cot square a is this what we got, and here now we are applying identity. That means we replace cot square a. That's nothing but square a. Is that correct or no? Third identity says it must be cosecant 1 minus cosecant squared a minus 1. Okay, cosecant squared a minus 1. This is replaced with that. Okay, then here also do the same thing. Cosecant squared a, cosecant squared a. Either you can do that or just the identity for this entire thing, you will get cosecant squared a. Okay, yeah. So multiply, you will have cosecant to the power of 4a minus cosecant squared a. It's proved. So did I use algebraic? Yes, I used actually the algebraic. This is the algebra. Okay, try to do the algebraic simplification before you apply the trigonometric identity. Okay, this is what the algebraic simplification. Yes, correct. So the next question. I don't think you will say okay, this also I can take, right? No, this is the fourth one. Yeah, secant a plus tan a divided by cosecant a plus cot a. Okay, so fourth. Oops, sorry. Is it secant, right? Yeah. Secant a plus tan a divided by cosecant a plus cot a equal to cosecant a minus cot a divided by secant a minus tan a. Right? Yeah. So there is nothing that algebraic simplification we can use here. There is no squares. There is no to the power of 4 or whatever. Okay. So then either you move from left hand side or right hand side. It's almost the same. In one case you have got plus, in other case you have got minus. Correct? So we have to use that reciprocal rule. Use the reciprocal stuff. Remember I said the powerful reciprocal stuff. I'll show you that. I asked you to remember that. See, this is what that reciprocal. Okay, this is reciprocal to that. I mentioned these are reciprocals. Okay, the third identity, if you have this, you can write this 1 by that. Okay, yeah, secant theta plus tan theta equal to, this is what the reciprocal thing. In fact, it's a third identity we are using in that way. Okay, so use the reciprocal from identity 3. Okay, so replace 1, then first one becomes 1 divided by secant a minus tan a. The denominator similarly becomes divided by cosecant a minus cot a. Yeah, see, this is the important thing. See, when I said that use the reciprocal, right, here I'm actually skipping 5-6 steps. So if you ask like whether I can write that, I said yes, you can. Okay, because after all you get the from your MF9 that no mathematical tables book, the identity. Yeah, you get that identity. You can say that from that identity you will write this is equal to 1 by that. Okay, so yeah, yeah, it's there. So you got the formula there. Okay, so then this automatically will go up cosecant a minus cot a divided by secant a minus tan a. Proved. One step. So what is the other method? How other people do is this. So they take LHS and they first multiplied secant a plus tan a with secant a minus tan a divided by secant a minus tan a, and keep the denominator no change, that cosecant a plus cot a. See, this is not disturbed, these are the extra things, they got it. Okay, so that's step 1. Then that will give you numerator multiplied, you get secant squared a minus tan squared a divided by this cosecant A plus cot A into secant A minus tan A. Yeah, this one, right? So the numerator is nothing but 1 by the third identity. So you have cosecant A, yeah, plus cot A multiplied by secant A minus tan A. Then again they'll do the same thing to get rid of the cosecant and cot A. Okay. Yeah, they multiply. Yeah, they multiply with cosecant A minus cot A in the numerator and the denominator. Okay, of the same thing, and you will have by entire thing. 1 by whatever you have here will be here. All that stuff. So then what happens? This cosecant A will multiply with this cosecant A plus cot A,